A question today that we went over in class, but I just didn't read it correctly, and you'll see when I get to that part. But let's go and do everything. So most of it, I think, 99% of the questions were pretty standard. Were pretty self-explanatory, pretty easy. So a number cube is tossed. Find the probability of getting an even number. 3 out of 6 or a half. A 4 or a 5 or means if you roll a 4 or you roll a 5, you would have won. So 2 out of 6, 1 out of 3. Greater than 6, well, there's no way of getting it greater than 6 on a standard die. That would have been 0 out of 6 or 0%. Less than 3 would have been 2 and 1, so it's against 2 out of 6 or 1/3. Right? Pretty easy. 3 plus 4 plus 5, I don't know what that is. 7, that's 12. So there's a total of 12. Let me write that down. So probability of getting a red would have been 3 out of 12, or 1/4. Probability of getting a green would be 0 out of 12. Not blue would have been red or yellow, so 7 out of 12. And the probability of yellow, 4 out of 12, or 1/3. Okay, so I still think you guys should have opted to go with this one. Create a list and a tree diagram. All the types of standards you can make. So tree diagram, let me start with that first, because then I can make a list second. So again, my starting point, and I'm going to do bread, and again, the choice was yours. You could mix it up. Cold cuts and sauce. So for bread, I had French or Italian, and with that, I could have had a ham, salami, or mustard. Same thing for the Italian bread. Ham, salami, or Italian. And then with each of these, I could have had butter or mustard. Butter, mustard, butter or mustard. And again, repeat at the bottom, butter and mustard, butter and mustard, and one more, butter and mustard. So the sample space would have been French bread with ham, with butter, French with ham and mustard, French with salami and butter, French with salami and mustard, and finally French cheese and butter, French. What did I write here? Ham, Sam. This should have been the C for cheese. French cheese and butter or mustard. I'm sorry. So we have 1, 2, 3, 4, 5, 6. Right. So it's 3 times 2 times 2. Okay, good. And then I can have Italian bread with ham and butter. Italian bread with ham and mustard. Italian with salami and butter, Italian with salami and mustard, Italian with cheese and butter, Italian with cheese and mustard. So I have a total of 12, right? And then if you did a fundamental counting principle, you have two choices for bread, 3 choices for cold cuts, and 2 choices for sauce. So 2 times 3 is 6, 6 times 2 is 12, which matches what we have here. Okay, that was a little bit of work. Sam has this should have been a coin, right? And a spinner. Find the probability of a heads and a 5. So the probability of heads is half. Probability of 5 on the spinner is 1 out of 8. So you would have had 1 out of 16. Probability of tails is half. Probability of even, let's see, 2, 4, 6 is a half again. So 1/4. Probability of heads is half. Probability of a 9, 0 out of 8. So that would have been 0 per chance of happening. Although you can get a heads, but you want to combine, right? In order to win, you would have to roll flip a heads and get a 9 on a spinner. So there's a 0% chance of happening because it has to be both. Heads is a half, and less than 9 would have been 8 out of 8. And you would have a 50% chance of that happening because this simplifies to 1. Okay. So far so good. Very, 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 very easy. Now this one. put a little star ahead of time. This is the one that I completely missed today. P of green and green, so the probability of getting a green is 5 out of 15. You're not putting it back, so it's the dependent probability. When you go back to the bag, you'll have one less green and one less in total. So simplify 1, 3, 2, 7, you get 2 out of 21. Green and blue, probability of getting a green is 5 out of 15. You put a green in your bag and you go back. You'll still have the same amount of blue, which is 6, but you'll have one less total because the green is in your pocket. So simplify 1 over 3, 1 over 2, 1 over 7. So that is 1 out of 7 chance of that happening. And then pink, a pink, and a pink. I'll do that one last. So the probability of getting a pink in the first try is 4 out of 15. Put it in your pocket. There's one less pink, so 3 out of 14. Put it in your pocket. Now there's 2 less pink. 2 out of 13. Can we simplify? Let's see, 1, 7, 1, 5. On the top is 4. At the bottom is 5 times 7 times 13. And 455. So we had a problem like this in one of our earlier check for understandings. So let's think about not blue. Let me erase this. So we have green, 5 green, 6 blue, and 4 pink. The probability of not getting blue on the first try means I either get a green or pink. So let's assume I got a green, right? So I'm putting the green in my pocket. But the probability of that happening, not blue, means 5 and 4 pink. So that's 9. I had a 9 out of 15 chance of happening. But I took a green out, right? And now I put that in my pocket. When I go for the second try, I want to get a pink, right? I'm going to have 14 here, but the pink, I still have 4, right? So that's one scenario. The other scenario, and that's what we have, and a plus sign here. The other scenario is where again, I'm going to get a not blue, and not blue either. It's what do you call green or pink. But let's say this time around, I got a pink. So, but the probability of getting a not blue is still 9 out of 14. But I did take a pink, right? So when I go to my pocket and I'm gonna go for the second selection, I don't have 4 pinks anymore. Sorry, this is 9 out of 15. Right, so when I go back to my pocket, because on the first try I got a pink, right? I'm gonna have 3 out of 14. And that's what I wanted to show you today. So you would add those two and give me the result. Yeah, so that was the main thing. Okay. 6. How many times can you expect to land on 2 if the spinner is spun 300 times? Well, the probability of landing on 2 is 1 out of 4 times 300. That's going to give me 75 times. How many times can you expect to land on a number greater than 4? Greater than 4 would be 2 out of 6. Multiply that by 80, so it's 1/3. So this problem here, so you have 80 divided by 3, so the answer is 26.6 repeating. You can't spin 26.6 of a time, right? So this would round up to 27. Okay. 7. Somebody rolled a die 10 times. Okay, the 1 came out 1 time, the 2 came out 1 time, the 3 came out 3 times, the 4 came out 2, the 5 came out 2, and the 6 came out 2. What's the experimental probability of rolling 4? In the experiment, which we rolled a die 10 times, the number 4 came out 2 times, so it's 1/5. What's the theoretical probability of rolling 4? Well, before you did the experiment, what's the probability of landing on a 4? P of 4 before an experiment is 1 out of 6. Based on the experiment, how many times would you predict to roll a 6 if you roll a die 10 times. On the experiment, the number 6 came out, right? 1 out of 6. If you multiply that by 100, it's 100 divided by 6. You get 16.6 again. So your answer should have been 17. Excuse me. Take a multiple choice test made up of 10 questions. Each question has 4 choices. How many different ways are there to answer the test, assuming you don't leave a question blank? Well, there's 10 questions. 3, 4, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the first one, you had 4 choices. You can do A, B, C, or D. The second, you can do A, B, C, and D. A, B, C, and D. So you have 4 choices in each. So I don't expect you to multiply 4 times itself 10 times. You could have left your answer as this. Or in a calculator, actually, you have a calculator. You can just go 4, arrow that points up, press 10, and you get 1048576. So 1,048,576 ways of answering this particular test. This one says can be repeated, so it's not a permutation. All right, so there's a safe with x, 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 y, y, y. X is number 0 to 9, and y represents the letter of the alphabet. So 1, 2, 3, 4, these are digits. 1, 2, 3, these are letters. So how many codes are possible for each of the following cases? The digits and letter of the alphabet can be repeated. So in the first spot here, you can choose from 10 different digits. The second, 10. The third is 10. The fourth is 10. The fifth, it's letters, so it's 26, 26, 26. So in exponential form, I would have taken that. And now Friday, if you have a question like this again, I'll tell you that you can leave that in exponential form. The digits and the letters of the alphabet can be repeated. So 1, 2, 3, 4. Again, these are digits. But you can't use zeros, so no zeros. And on the letters, you can use no vowels, but they can be repeated. So again, not a permutation. So for here, instead of 10 choices, you have 9 and 9 and 9 and 9. And the letters, well, A, E, I, O, U, there's 5 vowels, so 26 minus 5, we have 21 choices. Again, in exponential form, 9 to the 4th times 21 to the 3rd. So again, the only question that was really something that would have troubled you is this, because there's 2 different scenarios where this can happen. Okay? Yeah, that's it.